Hey, this is Don from Padlock Technologies again with another video, and actually got a question about this as well. So the question was basically, do I really need SSL decryption? Answer is yes, right? You, I have a saying that says you can't protect what you don't expect. So what I'm going to do is show you in the lab why you need SSL decryption based on the FTDs that I had set up. And then I'm going to show you a little bit more integration with secure endpoints. And then this is what I call stacking security, right? Or it's defense in depth is the concept, but I just call it security stacking, right? So let's go into the lab here. As you can see, I'm at a site that you test Ecard, which is a test piece of malware, and you can test to see if your firewall or your EDR can actually respond. Now, I would do this in a lab environment. Do not do this in your production environment because this is live malware. If you push this off in your environment and you don't have the protections in place, you can cause a problem. And again, it's another resume changing event for you engineers out there. So the first thing we're going to do is we're going to try to do this com file, and I do have secure endpoints on here. You can see it right there. So it's in there. So when I try to run this, it should stop it from being ran, and then I should see it in the firewall because I have it integrated. And then I'm going to also do the text file, and that should be stopped in transfer because this is, remember, it says use and secure SSL. So this is technically behind an SSL tunnel or being transferred within an SSL tunnel. And because I have SSL decryption, the firewall is going to do a man-in-the-middle attack, see it, stop it, and then we're going to see how the integration can go forward. So let's first run this file. So it's going to try to download this file. And as you can see, it's spinning and spinning, and then unknown. And then if I try to open the file, like it failed the last time. So if I try to open this file, hopefully secure endpoints will stop it. And let's see if it's here. I'm gonna open it in folder, see if we can find it. So this may have been stopped already, because I do not, yeah, see that file moved or missing. That means the secure endpoints has stopped it because it's moved and it's you don't see it anymore, or it's missing. Now let's do the text file. So I'm gonna try to do the text file here, download the same piece of malware virus, and then this should be blocked. And when I go to the firewall, you're going to see that it was blocked. You're going to see a malware event, and we're going to look at the logs. And I'm also going to, while I'm doing this, this is going to display the network as a sensor concept that Cisco kind of has. Now, the network as a sensor concept, if you don't know, is my sensor saw this. So I'm going to technically have this integrated with secure endpoints, and then I'm going to create a custom list, or I'm going to apply this to a custom list. And now this machine and that sensor that saw it, if there was another machine or another sensor in a totally different part of the world, once I create it to that custom list, if everybody's on that if everybody is attached to that same simple list, now I saw it in America, but when it got over to Australia or something, I already have it blocked because I took the SHA disposition and put it in the custom list to block it. So as you can see, this was connect reset error. So now that we did that, we see that the exploit did not run. So now I'm going to pull up my firewall here, and boom, here we go. Now, this is my summary dashboard. This is 742. I know I did 7.6 before, but this is 742, which is gold standard right now. And as you can see, incident of compromise came up and the malware threat came up. Now, this intrusion event, you'll see that these lines here is something I blocked, but this gives you partial information. Like I said before, go to analysis, and we're first going to look at the intrusion event. So the intrusion event was me trying to download that text file. Now, hopefully this doesn't, slow down. I am running this on a lab, so this may time out from time to time. Just want to warn you right now. So here's the go. Ecard test string download attempted. Now, it would have never known that if you didn't have SSL decryption on here. And remember, this is outbound decryption. This is not inbound decryption. Now, to get some further detail, you're going to go to table view of events. And that's going to show you exactly what happened. The results was blocked. It blocked it, and that's where you saw that connection attempt, right? the connection reset error. Now, show me that, this came from 192.168.16.0. Now, the one thing you do not see in here, when I go to the right, you're not going to see a username because this is technically I'm doing computer authentication. So if I really wanted to look and see what IP address that was, I would need to go to users, and we're going to show you that as well. So here was the source going to this destination, meaning it was coming back. That's where I was downloading it. It was going over SSL, which is 443. Now, my decryption policy, this is the outbound decryption policy that says, hey, I decrypted that traffic and then I re-signed it. And then I was able to scan when I decrypted the packet, I was able to see, oh, this is some malicious file that you're trying to download. And I blocked it. Without SSL decryption, wouldn't have happened because the firewall can't see it. Now, a little bit more detail is it's going to show you, hey, I did this. Firefox was exactly what tried to do it. And that correlates with what you saw, which I tried to download it through Firefox. It was coming from WAN 2 because I'm doing ECMP. So it could go WAN 1 or WAN 2. This decided to go out of WAN 2, right? Going out of my HA firewalls, INET firewalls. Here's the IPS policy that it hit. Here's the access control policy that it hit. It was the internet rule. And then it says the MITRE, which is malicious file. So if I want to view the technique that tried to happen, I would right click it, hit view technique, and it would show me. That was the malicious file or the malicious download. Now, if you want to get even more granular into the packet, you go back over here and you hit packets. My voice just jumped up for some odd reason. So now we're going to go to the packet. And this is going to show you the exact packet, right? So here's the snort rule right here. It is alert, any, and you will see IPS drop policy in here. And then you'll see a little bit more about the packet type, right? The stuff that it tried to drop or that it dropped. And then if you want to get really into the packet information, you can go to the data. You can see the string value, text, all that stuff. You can see all of that stuff. And as you can see, this is a standard antivirus text file. So that is what why you would need SSL decryption for this type of stuff, so your IPS can actually see it and stop it. A lot of people don't have SSL decryption, and this is why they get attacked, because their firewall can't see what's going on. So this answers the why you need SSL decryption on your firewalls. Every firewall should have it. Now there's some bandwidth issues as well. It's not as bad as it used to be. The rule of thumb used to be like you're going to see 40% bandwidth drop because SSL decryption, but that's not necessarily true nowadays. And you have to worry about certain things, like there's certain categories that you can't decrypt because privacy reasons. And then there's unencryptable data like Office 365 and stuff that you need to worry about. So that was the intrusion event, which is IPS. Now we're going to look at the malware event. So here's the malware event here. And that was when I was trying to do the com file. So here's the com file stuff again. And this is the most recent one. Now, you won't see anything here. This is kind of a summary. If you want more detail, you will go to malware events. And now this shows you everything. All of this. Everything got blocked, malware blocked, malware blocked. This is based on my malware policy. Again, your malware policy is only as effective as the stuff it can see. I've done so many assessments where people have a file and malware policy and an IPS policy and no SSL decryption. So it's like, well, who goes to normal web traffic nowadays? 99% of the traffic going to the internet is SSL. So without that, your malware policy and IPS policy is pretty much useless. So now, if we scroll over here, executable, that was that com file. Here's what's in it. And then came through Firefox. And this is look more detail, right? It was caught by my malware file and malware policy, right? So now, here is the beauty of the integration. Let's say I wanted to block this on all endpoints, even though say this was my HQ office. And my London office hasn't even seen this file yet. If you have secure endpoints integrated all over the place, with London office, just secure endpoints, period. And you have it integrated with your FMC. This is now where the network as a sensor concept comes in. So here's what we'll do. First thing I'm going to show you is, you see this file, SHA-256? This is a hash of the actual file. If you don't know what a hash is, I'll explain it in a different video. So what I can actually do is, since I have it integrated with secure endpoints, I can right click on this, and then I can scroll down and go to AMP for endpoints SHA-256. Now I could do file trajectory as well, but I'm going to do this one first, and then I'll go back and show you file trajectory. Well, I'll show you file trajectory. So if I click on this, it's going to open up secure endpoints. Now that's going to show you more data. File trajectory, I can show you that. It shows you that, hey, that PC saw it and the firewall saw it, right? The FMC saw it. So now, if I wanted to go file trajectory, I can click on, there we go. And now I can do outbreak control. I can look at the file trajectory down here. If I click on file trajectory, it shows me exactly what happened. Here's the transfer. Here's where it came in. Here's where it was stopped. Here's where it tried to go to another file. It's a whole bunch of stuff. Or this was observed here. Then we can show where it was actually, stopped or convicted. So this is where, your network security team or someone like us that's a managed firewall provider, we can actually go in and say, hey, this file was stopped. Look like the FMC saw it, and it looked like it was on this machine here. And it was stopped in its tracks. You can see detected, convicted, all that kind of stuff. So as you can see, the exploit was stopped. Now, here's the beauty of this as well. So we're going to click out of file trajectory. Let's say I wanted to stop this file now. Now I have a simple list that's already created, and anything that's in my group that's getting the secure endpoint client that's in a certain group called I think it's Windows. I think it's PLT Windows. That's what I call the group, and I have my own connector to it. All you have to do now to stop this domain-wide or company-wide is you right-click on the file here, and you say simple detection, and you add it to that list. So when I click add to that list, sorry, looks like that just took a little while. I don't know, my mouse is doing something. So I want to add it here. Let me right click again, because for some odd reason it's not showing up. All right, now it's added to the list. So now if I go to that simple list, so I go to my outbreak controls, I hit simple, and now I have one file in this list. All right, this is stuff that I added. This is an update. See, here's why I added the new thing to the list, a new SHA to that list. So now if I go back to my simple controls here, and you see one file, I have one file included there. That's the file. So anything that's connected to this custom list, which is, as you can see, the user group, PLT AMP Windows and servers, anytime this file is now seen, no matter where I am in the company, no matter where this thing gets transferred to, one, my sensor is going to see it. Number two, my AMP for endpoints, or my secure endpoint module, is going to see it and block it immediately, because it's in my global detection list, and it knows what to do with that, right? Now you can manually do this as well. If you have a SHA value that you know about, you would go in here, put the SHA value in here, put a note in here, hit add, and now that malicious file that has that hash to it will get stopped as well. And I'm gonna give you a brief example of the hash, right? You cannot change the hash. Basically, you put data into a hashing algorithm and it produces a hash. If you change the data even by 1 bit, it changes the hash value. So as long as they don't change, and most of these exploits, sometimes they don't change the actual data, the hash will always be the same. So as soon as you add it in here, it's going to be stopped everywhere else in your environment. Again, this is the difference between a lot of other providers and Cisco's integration, right? Their ecosystem integrates a lot better than most of them. And the simple fact that I can see something on my firewall here and then block it automatically at the endpoint level everywhere in my environment, no matter where I am, and just from a simple console, and go into custom detection list, bang, everything is, and now I don't have to worry about that malware actually trying to get executed somewhere. So back to what I was saying about, hey, this IP address, I don't know what that is, right? So if you want to know what that is, you would go to users. And as you can see, I have a couple of things here, LDAP. Now it's funny because some of these people I used to work with. So if you see this video, I'm just using it as an example. And we clicked on the user here, and I already know who this is. So if there we go. So now I know this PC is matched to this IP address. That user is being attacked. Need to get them off the network. I can now do RTC manually, go into ICE and, do something with the session. Or I can go into Stealth Watch, which I'm going to show you in another video, where I can go to Stealth Watch and do RTC there after I look at what kind of traffic is actually going to. Is it doing something malicious? And then stop it from there. So hopefully that video was informative. If you want something like this in your environment, there's going to be descriptions down below to do a discovery call. Schedule that discovery call with me, and we can talk about actually putting something like this in your environment to, increase your network security and your visibility about what's going on in your network. This is Don from Padlock Technologies. Thank you, and have a nice day.